Hey everyone, this month we're building a smart call center agent with OpenAI Agent Builder, where we walk step by step through creating a fully functional AI call center assistant that handles the calls for a fake mobile phone company. Agent Builder is OpenAI's platform for creating task-driven AI agents that can reason, use tools, and take real actions. It lets you define what the agent knows and what it can do, while OpenAI handles the planning and execution behind the scenes. With just a few steps, you can build agents that answer questions, automate workflows, or interact with APIs without managing any complex infrastructure. The Agent Builder is a drag and drop interface that is made up of nodes. We have start and end nodes. We have agents that will do particular tasks. We can add logic using while loops and if, then, else clauses. We also have a node called a guardrail that protects us from hallucinations, or it can protect us from disclosing private identifier information or from prompt injection, which is where someone is trying to hack our agent. Following the workflow from the start, we have a guardrail that protects us from prompt injection. Next, we see a triage agent that figures out what the customer wants. The agent then passes that on to 3 sub-agents. The first one is connected to the customer database. The second agent is a fine-tuned ChatGPT model trained on technical support questions, and the last agent is connected to a file storage that has FAQs and plan brochures in case the customer wants to find out more information about our plans. I've chosen this example as it uses a lot of the cool features of ChatGPT within the Agent Builder, such as using an MCP server or Model Context Protocol server to talk to the outside world, as well as fine-tuning to add our own questions and answers and file storage to add the mobile phone plan information. Now we know what we're building. Let's talk about how we're going to make it happen. ChatGPT is not going to know anything about our business, so we need to fine-tune one of the ChatGPT models to answer questions like when are we open, what is our address, etc. We might need a fine-tuned model for billing, one for technical questions, one for customer disconnects, but at the moment, we're just going to give it basic, help me, my internet is down type of questions. Every telephone business has a database of customers and the calls they make. So we need first to create that database, and we then use an MCP to connect to it. Basically, an MCP allows you to talk to a database or API in English. Next, we design the agent in the drag and drop interface so we have a working app that we can call from the command line. The easiest way to expose our agent to the world is using a chatbot. I also want to make this an IVR replacement, so I'm going to use Twilio to give us a phone number to call. Our fake telephone company is called Reese Mobile, and we sell mobile service. Typically, if I was designing the call center to replace a real system, I'd use old recordings to figure out who is calling and what are the most common questions our call center agents have to deal with. As I don't have access to any historical data, I asked ChatGPT to create 15 personas that will be calling my call center for my fake telephone company. As you can see, ChatGPT gave me a really good cross-section of users, from the frustrated my internet is down customer to the international traveler. ChatGPT also created customer scripts for each of these conversations, which we can use for our fine-tuning or training. The core engine of our technical support agent is a fine-tuned version of our ChatGPT model we feed in a list of example questions and answers, and merge it into one of the existing ChatGPT models. Where do we get the questions and answers? In this case, from ChatGPT. And once we get the questions, we put them in a JSON file called a JSON line file and upload it for training. When the model is trained, we can call it from within our agent, and if someone asks a relevant question, then it's going to give the provided answer and not what the model thinks is a good answer. Let's ask ChatGPT to generate typical questions and answers for Reese Mobile. The question and answers need to be in this JSON format, which we then need to compress into a single line per question and answer. The minimum number of questions and answers for fine-tuning is 15, but you should aim for at least 100 to 200 questions for any real-world applications. Once you have your questions, convert them into a question and answer on each line into what's known as a JSON line format. All of the code we're using is in a GitHub repository. You can find the link on the resources slide at the end of this video. Next, go into the OpenAI playground, click on fine tuning and upload your JSON line file. As yet, we can't train using any GPT-5 models, so we're going to use a GPT-4 model. Wait for the model to complete its tuning. My 100 questions took 30 minutes. When it is done, take a note of the name of your model on the left-hand side as we're going to use it later. Click on Chat in the Playground to test our fine-tuning model. Choose the model we just created. Ask it one of the questions you uploaded to make sure everything is okay. Next, we can reference our newly trained model in the agent we're about to build. Let's begin our call center agent design. Open the agent builder on the playground. Drag and drop a start node and an agent node onto the design area. Name the agent our mobile agent. Let's give it some basic instructions, such as you are a call center agent for a telephone company. Use your fine-tuning as a priority in answering customer questions. Connect our agent model to our fine-tuned model. Now click on the arrow to run the agent and ask it the same question. How do I upgrade my subscription plan? If you want to run the code locally, then first click on Code in the top right of the Agent Builder interface, then Agents SDK, and finally Python. Cut and paste the code into a new file called sampleagent.py in VS Code. Add your OpenAI API key to your environment file. Copy and paste the test workflow.py file from our GitHub repository. Again, you can find the link in the resources. Run Python test workflow.py from the terminal. Congrats, you are now running the agent locally. When I first ran this, I was having an issue printing the output, so I used the Evaluations tab back in the Agent Builder to see if the model was returning the correct answer. This is an excellent testing tool to see if your agent is performing how you would expect it to. You can also grade your agent. You can even get another model to grade the answer, which could be useful if you're regression testing hundreds of questions. For our next step, let's add a guardrail to look at how we can protect our agent. Click on the pencil to edit our agent. Drag across a guardrail node and connect it to our builder. I want to protect my agent from anyone trying to jailbreak it, so turn on the jailbreak. Many of the questions that our fake customers are going to have will be about their costs, so we need a fake database of customers and their call records. I asked ChatGPT to generate me some Python to create my fake database. ChatGPT generated the code, and I created several Excel spreadsheets of customers, call records, and plans. You can find the code in the Faker folder on GitHub. We have to convert the spreadsheets into a simple database so we can query it from our agent builder. Once we have it in a database, I can use an MCP server to talk to the data. I uploaded the generated customer spreadsheets into a ChatGPT chat and asked it to generate the code to put it into a database. It did not generate the code, it skipped a step and just gave me the SQLite file to download. Next, we need our MCP server to talk to the database. Again, I asked ChatGPT how to generate the MCP server code, which I put in the Faker folder on the GitHub repository. To start the server, install the MCP Python libraries and run app2.py. It's a very simple implementation that performs read-only SQL requests. You can add different calls to app2.py based on your call center needs. To make sure everything is working, I'm going to run the model inspector to see if it can connect properly using the npx command shown. Connect to the MCP server and click on Tools. Try Get Customer Calls. The MCP Inspector is very useful in seeing what tools we can call and also to make sure everything is working correctly. We're going to have to do one more step to allow our agent builder to talk to our local MCP server, and we need a program called Ngrok to help us out. Ngrok allows us to put our local host on the web so we can connect to it remotely. Install Ngrok from Windows Store, log in, and run the configuration command to get your authentication token. Next, run the Ngrok command to expose the local MCP server to the internet so we can call it from our agent builder. When we run Ngrok, it gives us a web address that we can put into the agent builder so it can connect to our SQLite database. Now connect our MCP in the playground using the public address Ngrok just gave us. We'll call our MCP server our mobile SQLite. There is no authentication on our server, so choose none. Now hit connect. If all goes well, you get a list of tools that we added in MCP server code. Change the approval to never require approve, as otherwise it'll stop every time it does a call. These tools were auto-generated by ChatGPT when we created the server, but as I said earlier, there is nothing to stop you writing or generating more calls. You all probably heard there are significant issues with MCP security, so I've made the server read only for the moment. You should also put some authentication in the server before you do any database updates, and you should also have checks for SQL injection. Okay, now we can ask our database things like, give me all the calls for Chris Cox. Once it's working in the chat, we can just repeat the same steps to get it working in the agent builder. We can also create a custom knowledge base of product sheets, FAQs, and other info you'd find on our fake telecom website. I saved the plans information Excel sheet from our earlier Faker library calls as a PDF, as currently file storage in OpenAI does not support Excel sheets. Go back to the playground and click on File Storage in the right-hand side menu. Upload our plan spreadsheet. You can also put up whatever else you want in there, like core values, product brochures, or frequently asked questions from your website. Okay, we now have all the elements for our call center agent. The triage agent searches for words in the call and hands it off to the last call agent, which has access to the database, the technical support agent with fine-tuning model, and the plan information agent, which has the plans and file storage. Here's the responses I got from our agent when I ask, hi, my name is Chris Cox. What was my last call? Or my internet is down. What do I need to do? Or finally, what family plans do you offer? We can call our agent from the command line, but that's not exactly user-friendly. There are multiple other ways to deploy our agent. We can make it a chatbot. We can call the agent using Twilio, and we can make it into a widget. We're going to do the first two. The widget doesn't make sense for our example as it just updates a single field. OpenAI gives you sample code that you can use to get a vanilla chatbot. A link to the code called the OpenAI ChatKit Starter app is on the resources slide. You can, of course, change the look and feel to match your own website. To get it to run, first clone the starter kit, next cut and paste the agent workflow ID and OpenAI API key into your environment file. You can find the agent workflow ID by clicking on the code tab in the agent builder. Then run the npm install and npm run dev commands. After running npm run dev, I asked it what type of family plans do you offer, and you can see the response above. Chatbots are great, but if we're going to try to replace or supplement our call center, then we need to talk to the agent. OpenAI has another demo app where we can use Twilio as a bridge to our agent. This app implements a phone calling assistant with the real-time API in Twilio and had two main parts, the web app and the WebSocket server. The web app serves as a front end for call configuration and transcripts. The WebSocket server handles the connection from Twilio, connects it to the real-time API, and forwards messages to the front end. To get this working, clone the OpenAI real-time Twilio demo repository, go to Twilio's website and create an account, then change directory into the web app folder, copy your newly created Twilio account, SID, and your Twilio authentication token into your environment file. Now run the command npm run dev. In a different terminal, change directory into the WebSocket server folder. This time, add your OpenAI API key into the environment folder. Again, run the command npm run dev. A setup checklist will appear. Follow the directions. Run the Ngrok command to get a public URL for your local server. When everything is done, click Let's Go. When you finish the checklist, you can now call the number and ask it a question like, how do I change my subscription? This was a lot to cover, but there is still lots more we could have done. Every call center runs on reporting metrics, such as first call resolution, average handle time, or customer satisfaction. You also need to be able to hand off to a human agent. At the moment, we can add a human approval in our agent builder, but as yet, they can't talk to our customer. Every call will have a wrap-up code, so we need to change our MCP code to allow us to write to our database. We need to add some security to our MCP server, such as an authentication token, and also to screen the SQL for SQL injection. Finally, OpenAI has a really good testing platform, under the evaluations tab that we barely touched on, we'd need to thoroughly test lots of call samples to make sure our agent is behaving properly. Otherwise, we run the risk that it will confuse our customers. And finally, here are links to the resources. First up is our GitHub repository. Next, some information on how fine-tuning works, and then links to the ChatKit starter app and the Twilio demo. If you liked our video, then there's more where that came from. Scan the code and join our newsletter to stay connected with the latest innovations from Reese.